Hi guys, my name is Ian, and this week I'm back with my solution for lesson number 7 in Paul McWhorter's Arduino with Python series. This week we are connecting a temperature sensor into the Arduino and then measuring that and sending the data through to Python. There's quite a lot going on this week. It's actually taken me quite a lot of time. There's a lot to do. Not least because I decided not to have just the DHT. I've added it in to the potentiometer that was there from last week, and additionally I happen to have a DHT22, so I've brought it into the story too. Anyway, let's get on with the show. Let's have a look at what we've got. So here we have the Nano. Old Faithful, it's already running the code, don't have to download it, which is handy. There's the pot. Nothing special here. The pot is wired over to analog pin A0. Next we have these two little modules, and this is where all the fun begins. These are digital modules. They're DHT, the blue one's 11, a DHT 11, the white one is a DHT 22. I'll get into the differences in a moment. Anyway, they are wired into digital pins. The 11 goes to pin number 3 and the 22 is going to pin number 4. The digital pins 3 and 4. Now, what's the difference between an 11 and a 22? Well, 22 is a little bit more expensive. It's also supposed to be a little bit better, and indeed it is a little bit better. It's more sensitive, more accurate, so it's I think it's good to plus or minus half a degree, whereas the 11 is plus or minus a whole degree. The 22 also has more range, as in a wider range of temperature it can measure over the 11. However, both these sensors are very slow. The 11, it takes, you shouldn't read it faster than once a second, and the 22 is slower still. You shouldn't read it faster than once every 2 seconds. And that initially gives us a big problem, because if you recall from the software that we were running last week, and indeed are still trying to run this week, we're reading the pot once every 100 milliseconds, so it's 10 times a second. And we're using a delay to control that, just a simple delay at the bottom of the loop. But now we want to read 3 things, all on different cycles. And additionally we want to print them out on a different cycle again. So it's 4 cycles potentially going on here, and that's when the delay command becomes pretty much unusable. So we jump into the code and we'll see the solutions. So let's have a good look at this code. So here you go. This is my Arduino code. This is the entire sketch. We've got some stuff for the DHT. This is the Adafruit library. You can just install it with the library manager. You set up, I've set up a couple of defines for the 2 sensors I've got. Then set up the pins. We've got A0, as I said, for the pot, and then 3 and 4 for the 11 and 22. Now this is where the fun begins. This is where we're getting into the different things we want to do at different times. You see I've decided to do the job 100 milliseconds. This is where I'm going to read the pot. This is where I'll read the DHT11 every 1000 milliseconds, or every 1 second, and every 2 seconds or 2000 milliseconds we do the DHT22. And then an additional job cycle, we want to print out the results we've got. Now, we'll get into all of this. This is where the real fun is, right? But we'll get to it in a moment. Let's skip through some of this code first. We have to initialize our DHTs. Then we have to initialize the pot pin and start the DHTs. This is all from the sample library code, not a problem. Then we start the serial. Now, how do we control doing 3 things, 4 things at once in a loop without using the blocking delay? Well, there are several options for it. We could start getting into interrupts, but we're not going to do that because there's a lot more going on than interrupts than what we want to do. The simplest way for us is to use the millis command. That allows us to basically keep a track of when we last did something. Now, millis is a command that counts the number of milliseconds since the Arduino was switched on. It rolls over about every, I think, 49 days. It's a long counter. But what we do is we use millis to keep a track of when we did something, and until a certain amount of time has passed, we don't do it again. And basically we're rattling around the loop as fast as we can, and we only go in and do something if a job cycle has been exceeded, if the time has been exceeded. So what we have is the time now, which we've stored up here, and we've got the time mark, which we initially set to the time now, so that we don't do things instantly, because we have to let these sensors settle down as well when we go in, so we don't want to do them straight away. And that's basically all it does. It checks if a certain amount of time has passed, that time being the job 1 cycle time, and if it has, it executes it. If it hasn't, it goes on and checks the next and the next and the next times 4, and that's it. And then it goes round and does it again. So it's going around the loop as fast as it can, and it only drops in to do things when a certain time period has passed, 100, 1000, 2000, or again 100 milliseconds. This is a good framework where we could be adding more things in, because believe me, doing something every 100 milliseconds is not, this Arduino is not busy. Doing something every couple of seconds, it is idle most of the time. So we've got plenty of hooks left where we can add more jobs into this millis cycle. Another thing of interest, I'm using static floats. Now obviously when we collect the temperature, we have to remember what it is. A static float is a way of using a non-volatile variable that isn't a global variable. So it's inside the loop, so it's close to where we need it. It's static, so every time the loop is run, it isn't reset to nothing, or the nan in this case. I'll explain what that is in a minute. It retains the value from one loop to the next. Now I could use globals in there, but it's good programming practice not to use global variables everywhere. Certain instances where you have to use it, interrupts being one of them, because you can't pass them parameters, but we're not doing that, so I'll try and keep the programming as good practice as I can, and static is the way to have a variable defined inside a loop that doesn't get erased every time the loop finishes. Anyway, on to nan. It means not a number. We set up all our variables for the pot and for the various sensors. We set them up to something before we start. We set the pot to -1 because you can't get -1, therefore I'll know that the pot hasn't got a value if a -1 ever comes across to the PC and into Python. These things, on the other hand, you can set them to not a number. That's actually what the codes, or the library code for this, will return if the sensor is faulty in some way. So not a number is what it normally returns if there is nothing to be returned. Not a number is a special number because it says it's not a number, but you can assign it to a float or even an int, I believe, and it won't trip up the type. That won't trip up the compiler. One interesting thing to note though is you can only set it as capital, not a number there in the code. If you tried lowercase, the compiler complains. But when we're sending it across later on, we'll see this later on, it comes across as lowercase, so I have to check for lowercase at the other end in Python. Anyway, this is my code. It's not terribly difficult. However, the millis and how to set up effectively, almost like a poor man's multitasking for an Arduino that can't do multitasking. That's basically what this is. Millis is our multitasking. Anyway, let's see what it looks like when we run it. So the code is running. If I switch screen to my favorite cool term, and we connect not to that. Let's see, file, open, and we want to connect to that, which is the same. Now, let's connect. Here we go. And in comes the numbers. Now, notice those nans streaming through, so if I just disconnect that, and we look at what we got. So initially, we had something for the pot, and nothing for the sensors. And then the first sensor starts coming in after 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's going every 100 milliseconds, so the 10th one will be a whole second. And then in comes the temperature and the humidity from the DHT11. And then we have another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we've got the next lot coming in. This is from the DHT22, and that's the temperature. These are centigrade, degrees centigrade, and then this is the humidity. They are different. In fact, I don't know why they're different. Could be sensitivities. They're right beside each other. My independent thermometer is telling me 19 degrees. The DHT11 is a good degree higher than that, but it is only accurate to plus or minus a degree. The DHT22 is telling me 19.3, so that's not too bad, to be honest. So there we go. And they just keep streaming out. Every 100 milliseconds it prints out another stream of numbers that it's read from the sensors, but it is only reading the sensors as per their own cycle, according to what we put in the Arduino code earlier. So there we go. That is the Arduino code, and I will stop this video here and do a separate video for the Python code, because it was a lot of work actually. It was very functional and very classy. So I will get to that later. In the meantime, this code will all be up on GitHub as usual, and I will catch you in the next video. For me, that'll be in about 5 minutes. Anyway, stop it here and get a drink.